get a fresh start here. Okay, so the problem was that we had two lines that were parallel whose slope is thwarting me. Whose slope was 3. There's a will, there's a way. Slope was 3. And went through the point -1, 2. Hoy. Technology is not my friend this morning. Okay. So the point slope form is y minus y1 equals m times x minus x1. And we just need to plug and chug. So we're going to plug in 2 for y1, -1 for x1, and 3 for the slope. And do very little simplification. We're just going to write that minus a minus 1. We're going to distribute that negative across and get x plus 1. So this is point slope form. So this is an equation that's parallel to y equals 3x, and it goes through the point -1, 2. Now, this is point slope form. If we want it in slope intercept form, then we just need to solve this for y. So I'm going to distribute the 3 across. Then I'm going to add the 2 to both sides. So there is a line whose slope is 3. So it has a slope parallel to the line we were given, but goes through the point -1, 2. All right. And if we look at the problem that we were given in my math lab, we can see that sure enough, if we look at this, that red line, the equation we were looking for, does go through the y-intercept of 5. So that equation that we got, 3x plus 5, is the equation that fits this red line. So it looks to me like we got it correctly. Got it correct. So write equation for that line in point slope form. So y equals 3x plus 5. Oh, what did I do wrong? Oh, I was supposed to put slope intercept form in there. Blah. That was, I'm supposed to put point slope form in there. Blah. So y minus 2 equals, and I'm not sure why this book does this, but it does, 3 parentheses, what was that, x plus 1? All right, and then slope intercept form, y equals 3x plus 5. Okay, the next problem, problem 2, you're given two lines that are perpendicular to each other. So let's go ahead and blow this up so we can see it. Find an equation for the line L, so the red line again, in point slope form and slope intercept form. L is perpendicular to the blue line, which is y equals 2x. So lines that are perpendicular to each other have negative reciprocal slopes. So if the line that I'm given has a slope of 2, slope of this line is 2, then the slope of the red line will be negative 1/2. You take the reciprocal of 2, so 2 over 1, the reciprocal would be 1/2, and then change the sign. So the slope of the line I'm given and the slope of the perpendicular line have to be negative reciprocals, because when I multiply those two slopes together, I have to get -1. So the slope of the line that I was given is 2. And the point is what? -1, -2? Okay. Okay, so we were given a blue line whose slope was 2. So this was our blue line. So the slope of the line that I'm interested in finding, the slope is going to be -1/2. So the negative reciprocal. So now we're going to find the equation of the line in point slope form and slope intercept form. So we have y minus y1 equals m times x minus x1. So we're going to plug in -2 for y1, -1/2 for m, and -1 for x1. Okay, so we're going to distribute that minus across. Y minus the -2 is y plus 2. -1/2 times x plus 1. X minus the -1 would be x plus 1. And now we need to distribute that -1/2 across. -1/2 times x is -1/2. -1/2 times 1 is -1/2. Now we subtract 2 from both sides. -1/2 minus 2 is -2.5. Right? We got -2 and we got -1/2, then we got -2.5. And I need to probably change that. I'm not sure if my MATLAB will accept a mixed number like that. I don't know if it will or not. I might. I could look at it and see. But I can change that to an improper fraction by multiplying the denominator times 2 and adding 1. That's -5/2. 2.5 is 5/2. So let's go give it a try. Okay, so this thing in point slope form was y plus 2. Take my glasses off, I can actually see better. 2 equals, what do we have? -1/2 times x plus 1, so -1/2, get my fraction. 1/2. I could have just typed in 1 divided by 2 and it would have done the same thing. Okay, now get out of my fraction, go over here, open my parentheses. What did we have? X plus 1? I think that is correct. We'll find out, won't we? Yay, got it right. So that is the equation of the line that's perpendicular to that blue line and goes through the point -1, -2. All right, what was our slope intercept form? That was y equals -1/2 x, so -1 divided by 2 x minus, and I don't think it'll let me write a mixed number, will it? I don't have a, let's see, do I have a mixed number in here? I do, right there. Do you think it'll let me write that? Let's find out. Was that 2.5? Let's see if it'll let me do that. You see my mixed number right next to my fraction, just to the right of the fraction is my mixed number. You think it'll accept that? Nah, I didn't like it. Oh, well, I tried. Is that right? Chickens. So, you know, it should accept -2.5. That's a problem with my math lab, not with the answer. If you want to be technical about it, there's no reason why you shouldn't be able to write those as decimals. As -0.5 x minus 2.5. 6 and 1/2 does it. All right, the next question I wanted to look at. I didn't look at a 10. What's 10 look like? That might not be bad. In 2000, 46% of the residents in a large city regularly used newspapers for getting their news. And this has decreased at an average rate of approximately 1.1% per year since then. Decreasing means that the slope is negative. If you're going from a larger number down to a smaller number, as x increases, if y goes from a larger number to a smaller number, then y is decreasing as x increases. So the slope is going to be negative. Find a linear function in slope-intercept form that models this description. The function should model the percentage of residents, P of x, who regularly use the news outlet X years after 2000. So if we're finding an equation that models this percentage, first of all, it says in the year 2000, 46% of residents were using the newspaper. So year 2000 is x equals 0, which is the y-intercept. 46% would be the y-intercept, because the graph of this thing starts at 46% and then goes down as x increases. So the y-axis, the start of this graph, when x is 0, y is 46. So the y-intercept is 46. Now what's happening is that each year, the percentage of people using the newspaper is decreasing, and it's decreasing by a rate of 1.1%, which means the slope is negative. So this would be negative 1.1 x plus 46. So did I get that right? Yeah. So when x is 0 at year 0, which is the year 2000, there are 46% of people using the newspaper to get their news. But each year that decreases by 1.1%. So in the year 2001, 1.1% less used the newspaper to get their news. And in the year 2002, it was 2.2% less than the 46. So this would be the equation that describes this situation. Yay, we got it right. So they give me the initial amount. So at year 0, they give me this value. And then they tell me how much it's going down per year. So that is the slope of this line. If it's a linear function, then that would be the equation that describes it. All right, so this is the one I wanted to look at. The function f of x equals 1.2x to the third minus 37x squared plus 261x plus 564 below models the number of discharges from the military, f of x, of active duty gay service members under the don't ask, don't tell policy X years after 1994. So that policy was implemented during the Clinton administration. So before you guys were born. So during the Clinton administration, he started the don't ask, don't tell policy. And this is the number of discharges after that policy was instituted. And it's modeled using this thing that looks pretty quadratic. I mean, that looks like a parabola to me. So find the slope of the secant line from x sub 1 equals 0 to x sub 2 equals 4. So you're going to find the average rate of change of the number of discharges from the year 0 to the year 4. So from 1994 to 1998. What's the average number of discharges from the military from time 0 to time 4, or from 1994 to 1998? So what you have to do is you're going to have to find the average rate of change, which is the slope of the line that goes through these 2 points. Now, I'm given 0 as x, and I'm given 4 as x. I'm given x equals 0 and x equals 4, but they don't tell me what the y value is. So I have to calculate that. So I'm going to have to get my calculator out and actually do this calculation. So I'm going to go back over to my whiteboard. If my whiteboard will cooperate. And I wrote it kind of messy, because my pencil's being kind of messy. See if I can neaten that up a little bit. So it's negative 1.2x to the third minus 37x squared plus 261x plus 564. And we want to find the slope of the secant line from x equals 0 to x equals 4. Is that correct? Make sure. Let me go back to the problem. Always a good idea to have the problem available so I can look at it. Number 1, it's not negative. It is positive, 1.2. Make sure I got it written down correctly. Just doing a quick double check of everything I have written down, 0 to 4. Okay, so we're good to go. So to find the average rate of change of this, or the slope of the secant line, that is the average rate of change. of this function. So to be able to find the slope, I have to find the change in y over the change in x. So I know what x and y are. Excuse me. I know what the two x's are. I don't know what y is. I don't know what f of x2 is, and I don't know what f of x1 is, but I can figure it out. Actually, I'm going to show you how to do this on your calculator. So what I want to know is I want to evaluate this function at 4. So I'm going to plug in x is 4 here, and I'm going to carry out this calculation. Now I can do this on my calculator, which is the way I would do it. All right, so let's go back. Let's open a calculator here. Boop-a-doop-a-doo. All right. Okay. So I'm going to do this calculation on my calculator. So I'm going to evaluate this function at 4, and I'm going to evaluate this function at 0. So I had 1.2 times, and I'm going to raise 4 to the third power. 4 to the third. Okay. Then I had minus 37 times x squared. So that would be 4 squared. Plus 261 times 4 plus 564. So this function evaluated at 4 is 1092.8. I'm going to write that down on my piece of paper. Now, I could plug in 0, but if I look at this function, if I replace the 4 with 0, the first 3 terms of this expression will go to 0. And what I'll be left with is 564. So the 564 is the y-intercept. If x is 0, whatever I find for y is the y-intercept. So f of x1 or f of 0 is 564, excuse me. Okay, so do I have that correct? Make sure that I did everything correct. Minus 37, 4 squared plus 4. Okay, that looks good to me. So I'm going to go back to my whiteboard. Okay, so now I'm going to carry out this calculation. So the slope of the secant line is the change in the y values, which I found, the 1092.8 minus the 564. Over the change in x, which was what, 4 minus 0? Okay, I'm going to take my calculator out. 1092.8 minus 564. And I get 528.8. Divided by 4. 132.2. So in the first 4 years, of the don't ask, don't tell policy, on average, 132.2 people were discharged from the military each year. On average, each year, 132 were discharged. And that's what the average rate of change finds for you. It finds this on average per unit. So since we're talking about years, time, starting at 1994 and ending at 1998, when you find this average rate of change, you're finding the average over that period of time. So on average, 132 people were discharged every year over the 4 years. So in total, 529 people were discharged over that 4-year period. So on average, every year, 132 were discharged. And that's what the average rate of change actually does find for us. How is it asking for the answer? So it says, the slope of the secant line is nearest whole number. So since it's asking me for the nearest whole number, it doesn't want any decimals. So it wants me to round off to the nearest ones place. So to the nearest whole number, which would be 132. Woohoo! Okay, so now it's going to ask me some more information. The actual average yearly increase from 1994 to 1998 was 140. So, I mean, military records exist. So from military records, on average per year, it was 140 people being discharged. Does the slope from part A underestimate or overestimate the value? Well, it's underestimating. So the slope of the secant line told me that on average, 132 people per year were discharged. In reality, it was 140. So my slope of secant line actually underestimates what actually happened. So it's underestimating. Okay, the slope from part A differs from the actual increase by, looks like 8. Because the reality was it was 140 people per year being discharged from the military during the beginning of the don't ask, don't tell policy. So it was our average of our secant line is actually underestimating the average per year by 8. So over the 4-year period, it's underestimating the total amount by 32 people. All right, and that's all I have for today, which it's actually 11:38 anyway. Does anyone have any questions, any homework problems, anything they want to see? In the 12:30 period, we will go over 2 problems from section 2.5 and a problem from section 2.6, where we do a little review there also. Any questions?
Oh, have you already covered the 2.6 and I just missed the whole section?
A 2.6 I covered on Tuesday.
Okay, then yeah, I need to go back and rewatch it.
We're going to do 2.7 today.
Okay.
I'm going to do a little review and then we'll do 2.7.
Alrighty.
Any other questions? All right, if you've typed your name in chat, I'm going to go ahead